Imagine that it's 12 a.m. and you have an exam tomorrow, and you get hungry. All the nearby restaurants and the dining halls are closed. So what do? This is a problem faced by most of the college students in the US, and a sophomore at Stanford came up with a new solution for it. Meet Anish, who is the president of the Stanford Robotics Club, and he was also part of the Winning 3 Hacks team that I interviewed last time. My name is Ahmad Zafar, and I'm an undergrad at Stanford studying computer science, and this is my podcast.
As I was growing up, I always thought that I'd either be like an aerospace engineer, I started designing aircraft, or I'd be a pilot. One of the two, because I've always loved aircraft my whole life. Hello, I'm Anish Bayya. I am a sophomore studying aeronautics and astronautics at Stanford University, and I am the co-president of Stanford Student Robotics. In fact, I think my passion started emerging when I was in 3rd grade, and my teacher had these little blocks. They're about an inch by an inch, and you can connect them together. It's these cubic blocks. So I started I snapped them together, and I made a line. And I made the line a small cross by adding sets of blocks to the side, right? And then I added some blocks to the back, some blocks sticking out the back. The next thing you know, I had a little airplane out of these cubic little blocks. And I remember running around the classroom with the greatest aerospace invention ever made, in my 2 fingers. And then I just thought to myself, you know what? From this very moment, airplanes will be my favorite thing ever. And nothing has changed to this day.
And that was in 3rd grade.
That was in 3rd grade.
Nice. How did your interest evolve after that? After that, your biggest single best piece of invention?
Whenever I go to the airport, I'd be like, Mom, that's a 737. Mom, that's a 737. Mom, that's an A380. And she'd be like, okay, cool, son. I'm proud of you. And then I remember one day, I went to the Boeing factory for a tour. My family went to Seattle, and they're like, you know what, you like airplanes, let's go see them. At the very end of the tour guide was like, remember guys, if it's not Boeing, I'm not going. And for the rest of my childhood, before I go on a plane, I'd be like, is this plane a Boeing? The flight attendant would be like, yeah, it is. And I'm like, cool, because if it's not Boeing, I'm not going.
Thank you so much, Anish, for joining me in my podcast today.
Thank you for having me.
So, Anish, let's start with your interest in robotics. Tell me, how did you become so passionate about robotics?
So, I believe my passion for robotics started to emerge at Stanford. Before I came here, I never really had much exposure to engineering. But I've always had a passion for aerospace, right? I've always loved aircraft. So the second I got to Stanford, my first thought was, how can I get involved? How can I learn more about this field that I really, really enjoy? So I joined this club called the Stanford Student Space Initiative. It's an amazing club that's just focused on helping engineers build towards space tech. For example, the team I joined was called the Satellites team. And what was really cool for me, was being able to engineer and build components for the satellite. So I started off, designing my first ever structure. It was a flat sat for a satellite. And what a flat sat is basically it's very hard to test all the components in a satellite when it's in a very tightly configured shape. So they like to lay all the components over a bunch of different flat boards. And I designed the modular system for that. Moving on, I designed other components that aided towards the creation of the satellite. And I really enjoyed the work I was doing. I was really learning a lot, and I was really happy, I'd say, just seeing my work contribute towards the final project. And then, I kind of realized that doing this type of work is something I really enjoy, and it's something I could see myself doing for the rest of my life. So that's where my passion emerges from.
All right. Let's shift gears a little bit, and let's talk about specifically your journey at the Stanford Robotics Club. So you were a freshman last year, you started working in SSI. Mm-hmm. And how did you transition to Stanford Robotics? And now you're in your sophomore year, you're the president of Robotics Club. So Tell me about that journey.
So I was involved with SSI. And then I eventually met the current president, the previous president of Stanford Student Robotics. His name is Andy Tang. He's a really cool guy, and I've worked on a couple of projects with him. So I'd find myself sometimes staying up late at night, organizing some stuff on a massive Notion sheet with them. And I started spending some more time around the club. Eventually, I had the idea to start up my own drone team here. And with Andy's help, I was able to get funding for an initial drone prototype. I'll show that soon. And from there, I started just getting more involved, building my team. And I go, hey, we want to expand to building a bigger project, the food delivery drone. And by then, people started getting involved with the project. I joined teams with Flight Club, which is another major engineering club at Stanford. At Stanford, they're really focusing on like building aircraft, a bunch of stuff in like the aeronautic side of aerospace. So together, we're working on the joint project to create an autonomous food drone. So I started getting involved with the community, building a team here. And eventually, every year, the position switches. So after working with Andy, and I let him know, I'd actually like to, I enjoyed working with you, running Stanford Robotics Club. And I know you're looking for a new president. I would like to be, I'd love to be one. And after some consideration, he chose me and my co-president to be.
Who's the co-president?
His name is Archer Date.
Okay, is he a sophomore?
He is a junior.
Oh, he's a junior.
Yeah,
All
he's
right.
a really, really cool, really goofy guy.
All right, so you mentioned the drone delivery project, and I know that you mentioned that to me before as well. So I'm really curious about it. Tell me more about it.
Why tell when we can show? I'll be right back.
Okay.
So, you hold the drone?
Yeah, sure.
This is our current testbed platform for the drone autonomy team. So basically, we want to create a VTOL drone to deliver food across campus, right? What is a VTOL drone? It's basically a drone that can take off vertically and land vertically, like a helicopter, right? But we're deciding to take it a step further. Having 4 props turning at once takes a lot of energy out of the system. So when you have a battery, it uses a lot of power. So our solution is we're going to design 2 wings to go on the side, right? And what these two wings allow us to do is we can put one more propeller in the front or the back of the aircraft. Therefore, when we get up to an altitude where we want the drone to fly, we switch on the propeller in the front, and we only have to use 1/4 of the power to power, 1/4 of the energy to power our aircraft, right? So it basically transitions from a quadcopter, that's like the one I have here, into an airplane.
Oh.
Right? So our mission capacity is to transport around 1 to 2 pounds. Across multiple trips on campus. And for context, Stanford is about 1 mile, just over a mile wide from campus end to campus end. So say you have a drone in the middle and you're going to one end of campus to a dorm to drop off food, right? And to come back, that's about a mile's journey. So we want our drone to be able to handle around 5 to 10 miles. 5 to 10 miles before we need to recharge it. Since, recharging takes some time. You need to buy a lot of batteries, which are quite expensive, and you have to spend time charging the batteries as well. So the idea of this drone is that this drone is a testbed platform for our autonomy programs, right? So the idea is when we move to our final, more expensive, heavy lifting drone to carry the food around, we want to minimize as many accidents as possible. So we're going to test all of our algorithms, our autonomy algorithms, taking off, going from point A to point B, how to get to point A to point B, landing, or picking up landing food, right? With this drone here. That way, when we move to our bigger design, we can move a lot faster and we can move with a lot less errors.
Okay. What has the Stanford administration said about it?
So currently, through Flight Club, we have authorization to fly over this part of campus called Lake Lag. Lake Lag is just a bit out to the side. And that allows us to do all of our robotics testing. Before we can have drones fly over Stanford, we have to prove that it's a very reliable, it's a very reliable drone. The idea is, this drone itself is probably about, we'll say like 2-3 pounds, 1 to 2 pounds, right? But when you're dropping that from 300 feet, F equals mass times mass times gravity times height, right? And as you're driving from large altitudes, a drone that's this light can really hurt someone.
Oh yeah, definitely.
Yeah. So we want to make sure that when our drone's flying for like hundreds of hours back to back, nothing bad can happen, and that our drone is reliable at those standards.
And what are the measures that you're taking to make sure that it does not drop?
So we're still currently engineering some solutions. So dropping is one thing. When you have wings on the edge of an aircraft, you can produce a lot of lift just from the momentum you have. Like the speed that the drone is currently at, you can use that. And as you're losing altitude, when you point the plane downwards, you can produce speed, which produces lift over the wings. So say that you're front propeller goes out and you can't produce more speed, you can glide the aircraft down somewhere safe to land. So you can point the nose down, and using some sort of algorithm that like we will implement, we can direct the plane to land, like say at a certain GPS coordination, like at certain GPS coordinates, or to find a safe location to land itself. Additionally, we're also talking about different methods to add a parachute to our final design. So if something really bad happens, like say there's a battery malfunction, we can quickly deploy a parachute and have the drone come to the ground safely.
All right, and how far are you in the testing phase right now?
So currently, I'm a sophomore. I started this program at the end of winter quarter. So that's around Marchish. And throughout spring quarter, which is between April to June, I met my co-lead at Flight Club and we started planning this new project. So over the summer, we built the drone, we configured it. I got practice flying the drone outside. So all the systems on the drone works. We integrated our autopilot software. It's an open source software that we can use. It's called Pix4. So we implemented that on the drone. And now throughout the summer, now throughout the fall quarter of my second year, we're launching the team. So, we hold meetings here at Lab 64 at 2 p.m. every Saturday, right? And a bunch of people come in and, this project is fairly new to me. I've never really built a drone before coming to Stanford. So I'm learning everything in the project. And while doing so, I'm also teaching everybody who's interested in the project so that we can all together really quickly get to the point where we can quickly develop on this drone and quickly make a lot of progress quickly.
So for students at Stanford right now who are freshmen or sophomores or anyone who is interested in this project right now, do you think they can join it right now?
So all the engineering clubs at Stanford, which I think is just an amazing trait, is no experience required. Look, I've never engineered anything before coming to Stanford. I gained a lot of my technical abilities this past year. And I think that is an amazing thing. Our engineering clubs here have the culture where we design you, our engineering clubs here are designed to teach you to learn, to give you hands-on experience, and most importantly, to have fun. You can really learn a lot of these clubs. You don't even have to be an engineering major. If you're any major, like an art major, an econ major, a history major, no matter what, even like a pre-med major, no matter what you are, you're welcome to come to our clubs and just practice engineering and just have fun.
But is there any limit to the size of the team, or is that open?
So generally what happens is there's a lot of interest at the start of the quarter, right? But as time goes on, people who are really invested by the project, by the meaning within the project, stick around, while a lot of people who are exploring where they want to find their place at Stanford go between multiple projects, right? So there's never an issue of too many people in the club. Honestly, the more we get, the better. Because if you're really, really interested in making a contribution and you apply yourself to the club, you can make an impact, and every single person who is really passionate about the project can really drive the project forward. So we have no cap. We want as many people as we can to build with us.
Makes sense. So do you think anyone at Stanford right now, if they have an idea of a project, they can come to a club, for example, like Stanford Robotics, and do you think they could build that project with a couple of friends under the supervision of the club?
So yeah, we love new projects at the club, right? So all we're asking is that when you come to the club, when you come to our club, you have they say come with a proposal, not an idea. Come with a proposal, come with a group of friends who would be invested in the project. Because for us, we love new projects to start, but our community here is about getting people to come to the clubs and learning and enjoying building, right? So we want projects where people are welcome to come and, welcome to just start engineering, just to have fun with what they're doing, right? Open to anybody. And your project should be something that a group of people can work on, and it should be just a good proposal, nothing too complicated, and we'll help you with the proposal along the way. So the way, if you think about it, is if you want to build something cool with your friends or something cool with a bunch of people, we are your allies, and we will help you bring your project to life. So just come approach us, and we'll help get you started.
All right, and what if those people are not from Stanford? What if they're from across the US or even internationally? If they want to get involved with Stanford Robotics, do you think there's a way?
So that's a very particular case. Generally, if you want to do a project as Stanford Student Robotics, you should be a Stanford student because the funding that we're getting from the university is applied directly to our students. Now there is a case, for example, our drone ecology team. So this spring they went to Costa Rica and they flew drones over the ocean to find an endangered species of shark. And they partnered with the university in Costa Rica because this university had a lot of aerial footage of this drone, right? That way, using their data, you can create an ML algorithm for a drone to detect the shark. Because think about it, if you're a researcher and you're flying in the ocean, it's very, very hard to find like an endangered shark. So if you have a drone that can detect that for you, it makes lives a lot easier. So that's one of the instances where we would work with another university, another group outside of Stanford, for projects like these. So I'd say if you're like another student organization and another club, you can reach out to us and see if there's people who might be interested in a collaboration project, and we can help branch that out for you. Otherwise, for personal projects or for personal groups, we generally stick to Stanford students because that's where our funding goes to.
Makes sense. Okay, I'm going to step back a bit and talk about the inspiration behind the drone delivery project that you had. So tell me, like, where did that idea come from?
I believe I mentioned Andy before, and I've always thought about it'd be really cool to build a drone just to do a bunch of autonomous tasks for us. So one late night, I was just hanging with Andy because him and I were becoming close friends. Besides for the stuff we do with robotics, we'd hang outside. So I was sitting with him, another mutual friend, and I was like, I had this crazy idea of an autonomous drone network. Bunch of drones flying around, doing a bunch of autonomous tasks. They'd have like a hub, power station, just a bunch of I was just spitballing my idea that I spent some time thinking about every now and then. And then he texted me a couple of days later going like, Anish, I love your idea. Come to robotics, we'll help fund it. This would be amazing. We'd love to have you. So then that's when I started coming around the start of winter quarter, which is around January-ish. And I would come spend some time with Andy just building random robots with him and talking about my idea. And eventually, I gave him a list of parts for the drone I wanted to build, just a prototype to prove I can build a drone in the first place. I actually have it right here. I'll be right back. Okay. This is what we call the Mark 1.
Okay, nice.
And this is the first drone this is the Mark 1.
Nice.
This is the first drone that I built. So I'd spend a couple late nights here on that desk over there.
Nice.
Yeah, just soldering, figuring out the connections, making sure all the circuits were aligned.
What have you used in this? What chip?
It's a SpeedyBee flight computer.
Okay.
So there's a flight computer at the top. That's the top board. The board under that is called the electronic speed controller. Because the electronic speed controller, there's about 4 of those. They're all in one board. And each of the speed controllers communicates to each of the motor. That way, just like a good chip in the middle to make sure all of the voltages are going through the motors at the right speed, and you can control the motor inputs and outputs, right? The motor inputs.
Yeah.
So it's a very important process, and the flight controller gives that signal to the electronic speed controller below it. Oh, do this, do that.
Okay, makes sense. That's pretty cool.
Yeah. It's honestly, I feel like I made it sound a lot more complicated than it is. At the end of the day, sure, can I see this?
Yeah.
I might tell you guys, oh, hey, go build a drone, right? And this is one of our intro projects here at the with my drone team. If I tell you go build a drone, you'll go, where the heck do I start? If I tell you, hey guys, actually, I know you've never engineered before. Build a fully autonomous food delivery drone. Where do you go? It sounds very complicated. It's like I'll have to create all of these autonomy scripts, maybe like vision learning, maybe like just insert a bunch of complicated terms. I have to make sure the drone, is dynamically stable through control feedback loops, so the drone doesn't topple over mid-flight. A bunch of complicated terms, but we can break them down step by step. So maybe building a drone's daunting, but we can break down each part of the drone. Like you have your propellers, you have an electronic speed controller, you have a flight controller, you have a radio. You have a flight controller. You have a radio that connects to the flight controller. What? So from your radio in your hand, you can send a message to the radio controller. It'll communicate to the flight controller, which will communicate to the electronic speed controllers, and that will vary each prop. And there's algorithms out there that do all of this automation for you, right? So when you put the input to increase your throttle, it makes sure that the power distribution is even in each of the 4 props. And that sounds a lot simpler. And I go, okay, let's find each of the components we need to use. Now we have each of the components for the drone. We can build it up, right? Solder some stuff together. Nothing too hard. There's just a small station there. It's a really easy skill and a really fun skill to learn too. And just through online software that's already out there, there's a bunch of programs to easily configure your drone. So you just click some buttons and your drone's ready to fly.
You didn't have to write your own code.
No, you don't have to write your own code.
Okay.
I mean, for the food delivery drone, we'll be writing our own scripts, but
that would also be kind of modifying the existing on the side.
Yeah, so basically there's this platform called Autopilot, right? And with Autopilot, they've created a lot of open source algorithms for us to use. And the most important ones is okay, there's modes like stabilize. That makes sure that there's a gyroscope that can just tell how much you've tilted on the drone, if your drone's tilted in any of the directions. So that can just send the inputs to each of the 4 motors. So say you're tilting backwards a bit. This motor speeds up and you're stable again. And it does that feedback loop for you, right? So that simplifies the process. So you can you can upload that quickly to your drone, and the open source software does that for you automatically. You don't have to manually do that. It's just all of the nitty gritty hard stuff that makes drones hard to fly. That's all been done. That's all in a computer chip, and that's all free to use. So you can quickly configure your drone, and you can just fly it.
So what's the challenge here then? If you want to make this a reality, delivering food to Stanford students on campus right now, what are the challenges now?
Okay, so I'd like to just point one thing out, right? When I first told you, let's build a drone, it sounded really complicated, right? How do you build a drone? But I explained you some of the processes. Now you said, what's the challenge? The drone doesn't sound too complicated, right?
Yeah.
Okay, but now I say, let's build a food delivery drone, and you're back to,
how do you add the food delivery aspect?
Yeah, how would you do that? That's the challenge again, right? So in the same way, I try to break down, how you build a drone. I like to break down how you build the food delivery drone. And there's a lot of aspects to it. I can be let's design a propeller to create, let's design quiet propellers so it's not loud and noisy anymore. Let's put a depth sensing camera in the front, so if a bird flies, we can avoid hitting it, right? We can add multiple parachute systems and stuff. That sounds very complicated. So our process is, let's take it step by step. First step is, okay, you want the drone to be autonomous? Let's have the drone take off and land by itself, just through a computer script, right? That's not too hard to do. That's not too hard to do. There's a bunch of open source software out there, and you can just, using an API, in this thing called DroneKit, you can program the drone to take off and to land. It's a very easy Python thing. Now maybe some of the annoying stuff you have to go through is you have to set up a Linux machine. You can use a virtual world on your laptop, and you have to download a bunch of scripts. You have to download Autopilot, make sure it works, communication protocols. But each thing I mentioned is just that's about an hour of, that's a small thing I have to quickly figure out. I can break the complicated step of how do you make a drone take off and land by itself into a bunch of smaller steps, which inherently all by itself is not too complicated, right? Now the small step of taking off and landing, that's cool. Let's have the drone take off, fly to point B, and then land. That's the step more, but that's only one step more. Now let's have the drone take off, go to point A and B, so it flies around our lake without going over the water, and land. Okay, that works. Let's have our drone take off, fly around the water now without going over it, land at point B, take off and land back to us. Kind of like a food delivery drone, right? And you keep building it up. Eventually you go, hey, instead of using select GPS points, let's instead have a grid. A grid of points that a grid of GPS points that within this range, a grid of GPS points that the drone's allowed to fly over. And okay, let me think of that. Let's use a grid that specifies whether a certain GPS location is good for a drone to fly over. For example, we don't want the drone flying over the lake, so we make a no-fly zone. Instead, we can have the drone fly around the lake. And we can make a small pathfinding algorithm to our previous algorithm for the drone to autonomously fly around the lake, land, take off, come back to us, right? What's the next step? When you land there, open a small box at the bottom that drops like a candy bar. Eventually, we'll want to make more complicated systems where the drone's in the air And kind of like, the company Zipline, it can deliver a package
Yeah.
down, release it, and come back up. But that's a complicated process. And just like how I broke down, how do we get the drone from point A to point B, we'll be breaking down that step too. Eventually we'll go, hey, we want to design propellers that are quiet. Our drone already works, and we're testing to make sure it's a very reliable system, right? So while the brunt work of our drone's done, we can spend some of our energy designing this propeller. Let's look at vortices now. How do you make a propeller quiet? When the propeller is spinning, it creates a lot of wake vortices, which is disturbance in the air. By minimizing those frequencies into frequencies that we can't hear or we're less likely to hear, you can reduce the amount of sound that comes from the propellers. Sounds very complicated, but just like I said, just like how I broke down the autonomous drone flying, we can break this down too.
Yeah.
My goal as the team lead of this project is to make really complicated tasks simple. Because I truly believe that a really complicated task can be broken down into a bunch of simple steps, right? Really, really big projects like what you see SpaceX doing, for example. It's a very complicated, hard to do system, right? But when you break back each step by step, it becomes simple. Calculus to a person who's never done calculus is very complicated, but once you break down each of the levels to build up to calculus, and you get used to using calculus, it's not so complicated. And you can use that calculus for more complicated systems like differential equations and stuff, right? So it's like one step at a time.
Is that your philosophy in life, to break down every complex stuff? And that's that thinking is a lot like philosophy.
I would say that's a good way to approach life. I think far too often people, and I've seen many engineers who are interested in working in our clubs and stuff, they come up to me oh, how do I build this? I have no experience, right? I don't know where to start on this project. And it scares a lot of people. When you think of a really big project to work on, it's complicated, there's a lot of steps to it, you don't know where to start. But if you break it down, what is initially daunting can appear to be simple. And I think breaking that down just really helps the day-to-day life. Say, for example, I have a lot of homework to do one day, right? Okay, I have a lot of homework to do. I'm feeling stressed. I don't know how I'm going to get it done. But then I'll break down each assignment piece by piece. I'll do this assignment this day, this assignment this day. I'll work on these questions, right? And then just assigning everything, breaking down my workload into steps after I have a solid plan of what to do, and I feel a lot more calm because I can execute in something I can work on, versus of thinking, oh, I have to do my homework. That's a lot of work to do, right?
Okay, break this down for me. You have everything, you have the product ready, everything works perfectly. How do you make Stanford students or any college students use that? Build this reality for me. What would that look like?
So how Stanford students would use our drone?
Yeah, for example, I'm sitting in my dorm. How would that work? How would I order the food, and how fast would it take the drone to deliver it? And paint that reality for me.
Okay, so our flowchart for how this would work would be a student, hungry late one night. It's 1 a.m. The dining halls at Stanford close at 8. That's 5 hours since you've last eaten. 5 hours. You're kind of hungry. Maybe you ate at 6 because you had to get an early dinner, right? So, you go to your phone and you select, hey, I want to get some food. So all the on-campus locations that are open, you can select one of the locations, make your purchase for that order. Our drone will take off from a hub. It'll fly to the location from where you picked up your food, drop down, pick up the package, pick the package back up, fly to your dorm at a designated landing spot, drop down its package, release your food, lift its container back up, and either do another mission or go back to base and land and recharge, or any of the tasks that needs to be done.
I think that would be pretty useful. But are there other companies already working in this space?
Yeah, okay. Yeah, there are a lot of companies working on this. For example, the major leaders in this field are Zipline and Wing, right? And they've already have a lot of these concepts figured out. A lot of our inspiration for our drone, for example, making it half drone, half airplane, comes from companies like Zipline and Wing. And when you really think about it, looking at them is a really good example of what we should be doing, because they're the ones who put a lot of research, a lot of I put a lot of effort into learning about the autonomous food delivery network, in urban areas like San Francisco, right? I think this project more for itself to be something like too revolutionary is to be something where this project is to show that Stanford students are capable of building something as complicated that a major company like Zipline is doing. Now, will our drone be as good as Zipline is? That's up for debate. Probably not, because they have hundreds of like fully employed employees working in that, and they're a really, really good company. Like this is people's lives come from working with Zipline. But us being able to create this prototype, being able to bring a service to Stanford, like this I think will be a Stanford idea, and this will be a service to Stanford students, because what you can learn in this project, you can apply to plenty of other fields. Definitely. You can apply all of the engineering topics to other engineering fields, or like other engineering projects or other companies. Honestly, like working on this project itself would make you a perfect candidate to work at a company like Zipline, I would say, because you're literally doing what Zipline is doing, right?
Yeah.
So it's just really like for me, I think this project's really cool, and I've found that I can tell people, hey, come work for Zip, come work for my drone delivery. It'd be cool. You have fun. I'm like, oh, cool. I'll come by when I'm free. But I found out when I really speak to the message of the product, it's like a really cool drone. You're really like creating something great for Stanford. Imagine being able to say, hey, Stanford students built an autonomous drone, right? And imagine me being able to say, hey, I built an autonomous drone. Hey, I can order food and it'll come to me 1 o'clock in the morning, right? Being able to be a part of this project, I think the project itself inspires and really gets people, wanting to work on the project. For me, it's about inspiring people to want to come into engineering and really enjoy building stuff that they want to build. And a project that is this complicated as an autonomy food delivery drone, I feel like if you tell that to any student, they'd be scared away. Like, oh, that's too complicated. Like, people working on that must have a lot of prior experience. They must have done a lot of research, or must have done like internships in the past and only know how to be crazy engineers, and I can never do that. But I want to show the message that anyone can be an engineer, and all you have to do is like just show up, be curious, and learn. And every single complicated task, you can break down into simple steps, and you can learn the skills you need to be an engineer. I want to show you might. I've never built a drone before, but just by applying yourself and by being curious and being excited to learn, you can build something as beautiful and as complicated as this.
Definitely. I think that's true for me at Stanford as well. Like when I came to Stanford, I didn't have a lot of programming experience, but when I started taking those classes, it was like, it's hard at first, but when you start to push yourself through it and show up every day, like be consistent, it starts to become easier for you.
True. I'd say like one of my experiences here is like, there's this common feeling at Stanford called imposter syndrome, right? It's tossed around here a lot. It's like, oh, like I'm not good enough to be at Stanford. There are a lot of people who are better than me, right? How will I ever thrive here? But what I've come to realize, what really helps me is like, I have some really, really close friends who are by all means amazing inspirations of people that I strive to be. They're so much better than me, and honestly I would love to be half as good as an engineer as them, right? But what I find is that instead of being like, oh, I could never be as good as them, I find myself being inspired by them, and I want to be like them, right? And I think that really helps a lot. Like when you're coming to an environment where there's a lot of like really amazing, a lot of brilliant people, just being inspired by the work they do and driven to be the people they are, really just helps you as a person.
But that's like a different, that's a really hard thing to actually implement in your life, because at Stanford everyone is like a valedictorian and everyone is at the top of your game, like in high school. But when they came here, when they see people even like more prepared than them, or maybe having better skills than them because they've spent more time, people, instead of being like inspired, there might be some feelings of that this person is better than me, and some form of jealousy. But
I know what you mean.
Yeah, something like that.
I think that really depends on like the person you meet, because there's some people who are really smart and they know they're smart, and they'll be like, hey, and they kind of scared, like, I'm a really smart person. They act like they're in a league above you, or they're maybe like they don't really know you too well, and they're just like being themselves, like really, really smart. But then like for me, like one of my closest friends, his name's like Krish, right? Like I knew this guy who was just like a lot smarter than me. He'd like lead in a way that was very inspiring. He'd think very creatively, very very elegantly. Like, you know, he has a lot of experience and he knows how to get things done in a very like he can make, like when he works on something, he can make, let me say this, like when he works on a project, he can take the project to an extreme level of good, right? And just getting to know him, I feel like if I just saw him from afar, I'd feel like I could never be anything like him, right? That's scary. It's like, you know, he's too cracked or like he's too smart. I can never be like him. But after getting to know him, and just from the character he is, the type of friend he is to me, right? He really inspires me to be better. He's like, you know, he builds a lot of self-confidence within myself. Like he really shows me like, you know what, I'm very capable for the things I'm doing, and that, you know, I should not be like, you know, I shouldn't be hard on myself. I can really do a lot, and I can learn quickly, and you know, because I'm like with the passions I have, I can learn quickly and I can make an impact in the world, right? Yeah. And it's because of like people like him, and there's like multiple friends like that I have like a lot more confidence, and I you know, although I might be around, you know, like although everybody around me might, although I might feel like everybody around me is smarter than me, like, you know, I feel like I have a belonging and I'm growing here as a person. And, you know, when it comes to new people at my club, the same way that Chris treated me as a friend, I want to treat all of, you know, all of our new engineers, all of our engineering members at our club are on my team, to be like, you know, like a lot of the engineers here have a lot of experience and they've been working on these crazy robotics contraptions, but you should not be scared. Like, we hope to inspire and to like really like, you know, like embark a lot of curiosity, a lot of passion within our students to like want to keep building, want to keep learning more, and just to keep improving on themselves. And like that's the message I want to keep driving forward.
Any last message for maybe new college students who are looking to get into robotics and who are trying to learn to be as technical as possible? Any general advice, honestly?
I mean, if you're at a university, I believe most universities have an engineering club, and if you're looking to get involved in engineering, just join the club and work on the project. Maybe, you know, I've heard of instances where some engineering clubs aren't the best, right? But you yourself as a person can really like drive a project forward, and you can really like, you know, you can inspire the people around you. You can really enjoy, you know, you can build a project you're really passionate about, right? Get involved with what's at your school. If your school doesn't have an engineering club, I'd encourage you to start one of your own. Think of like instead of just starting a club, think of a project you can work on that you've enjoyed. Most of the engineering clubs at Stanford started off in a similar way. They had like a project or a project or a competition they wanted to compete in, and they just start a club up, and then the club would just grow as people are like really like, yes, people really enjoy engineering and building things, and you can start a really good community like that. If you're outside of university, I just encourage you to just, you know, find a way to start building something. There are plenty of like, let me think about this. There are plenty of small projects you can start working on the outside. You can get a microcontroller, like an Arduino, for like less than $50, right? Yeah. And that Arduino is very powerful. For example, you can program LED lights in your room. Yeah. And you can have like, instead of like paying like $50 for LED lights, you can make your own, and you can program your own software for them.
Yeah, and if you're taking 107E, CS 107E, then you can, you know, build your own clock.
Exactly. No, or your own like Raspberry Pi.
Oh yeah.
But no, just like be curious, start building. I know a lot of the people here, a lot of the engineers here, just start building a lot of things on their own. I was talking to a guy earlier today, and he was like, "Oh, I'm a freshman here." I'm like, "That's cool." And he's like, showing me a picture on his phone of a rocket he built. It's like a small little model rocket, but I saw like it was a really, really cool picture. Like all like the flames and the sparks flying down. The rocket was just taking off on an angle, and he was talking to somebody at SpaceX, and I'm just like, SpaceX, like hire this guy. Like, you know, you can like buy a model rocket set, for example. And you can start designing your own model rockets with just some of the tools you have around you.
Yeah, and that's very true. Like, I'm from Pakistan, and we don't we have a lot of resources there, but not as good as compared to the US. I would say, like, that's a fact. And my journey with robotics and electronics started in my high school club. In the electronics club, I used to, you know, go there in my free time, and we built shoe for the visually impaired using Arduino actually.
Really?
Yeah. We
Wait.
use like the sensors in the top, and it's pretty cool.
So what was the results of your work?
We participated in a graduate level competition in one of the
Wow.
top technology universities in Pakistan, and we won third prize.
Third prize.
Yeah.
Wait, so how does that, how do the sensors work? Like how does like the
Yeah.
how
So
does this the user?
basically, they detected distance, and for example, if someone is wearing that shoe and an obstacle comes to a certain distance, the shoe started beeping.
I see.
Yeah, it was a kind of a very prototype based. We could work more on it, but there was not a huge market, and then there are like business models that you have to look into before launching that project further. But it was a cool experience.
Like your idea, like you get to a certain distance and you get feedback. I think as we were downstairs talking earlier, we saw this cool robot that drew your podcast's name on a canvas.
Oh, yeah.
You should show a video of that, right?
Definitely.
Yeah. What's cool about that system is when the robot touched the canvas, to the operator who was like operating the operating like the drawing robot from the side, you get a haptic feedback, which you get like a force is applied on your hand, so you know you're touching the wall. So like for example, like when I was writing my name, I could feel it was like writing on a normal piece of paper. I like that haptic feedback. So like that reminds me a lot of like your project. You move to the wall, you get feedback. Maybe like what my research lab would do is when you get to the wall, you have a small stepper motor in the foot that would push down against your foot, just very lightly.
Oh, yeah.
And then like there's a wall here,
No, definitely. I think there can be multiple use cases of that. Maybe you could connect it to everyone has, like a lot of people have smartwatches. Maybe it could like vibrate on your smartwatch.
That's an example of haptic feedback.
Yeah, exactly. But you talked about your research. I want to focus on that. So being a sophomore right now, you're involved in a lot of research. Tell me about that.
So I can't go into the details of my research too much because a lot of it, it's a lab-based research, so it's all kind of confidential.
Okay.
Since a lot of the
sure.
work they work on turns into patents or can like evolve into commercial use. But basically, what I worked on are these soft robots called vine robots. You should like overview like a robot of a video of a vine robot growing, right?
Yeah.
And as you increase air supply into a vine robot, it can grow outwards and reach like really hard to reach places. So for example, like moving through, like for example, if you're trying to move through a pipe, right? You can't like exactly like drive a car in there and then see like a really small car, but you can grow a small inflatable robot to go through like a small pipe, and with some instruments at the end of the robot, you can get like a video of that, for example. So what I worked on was like just a couple, some hardware that goes on the vine robots that can grow with the vine robot, right? That way, like as this vine robot is going forward, say you have a camera on the front, you can keep the camera on the front of the robot. So I worked on a lot of like soft robotics like that, and I got to spend the summer. I stayed this summer working on some of this research.
So what are some of the applications of the soft robots?
So there actually are a lot of applications to the robots. A YouTuber called Veritasium, he made a YouTube video about vine robots, and he went over many of the different applications. So they can be used to reach, very hard to reach places. They can be used as like an air supply down somebody's throat, right? You can grow like this inflatable structure. They've been used in space before, for example, to deploy some solar panels. You have an inflatable beam that grows out, and you can drag a load of solar panels with you. I think they're using them for, there was a design for a Mars, I'm not too sure about the last one, so check the video first before you post the last one in there.
Sure.
Yeah, this one. So there's a video, there's like a Mars lander that uses a vine robot to dig away some dirt below it, right, to reach like a hard, to reach like the soil below the ground, right? So from space to medical hardware, there's a lot of applications for vine robots.
Interesting. So when do you think the results from that lab would be actually transferred to the industry?
I mean, right now, like I can't exactly talk too much about the specifics, but for example, like I've seen my mentors in the lab interview a lot of people in the industrial field, and they've been doing projects with people in the industrial field. And so far, like they're finding a lot of good uses for the vine robots. People are happy with the results that these vine robots are able to achieve for their basic needs. And there's, it might not be as big as the automobile industry, but okay, that sounds stupid when I say that. Okay, there might not be a massive industry, but there's definitely a lot of applications for Vine robots.
So thank you so much, Anish, for this interesting conversation. And I think we'll keep in touch. I might just show up to the lab and just see what you're working there with the drones.
Come by tomorrow.
I would really love if I'm hungry at 12 a.m. and I just order food and it comes in like 15 minutes.
Exactly. Like, why bike to late night dining
exactly.
when you don't have to get up at all and your drone will just come to you?
Yeah, just get it from the window.
Yeah, it's from the window. Here's food.